Alright guys, I'm very excited to tell you I found a quiet place to make some more of your videos. So here goes, continuing with the big theorems. The total order and transportation cost, measured in dollars, of bottles of Pepsi Cola is given by this function, C of x. X is the order size in number of bottles, in hundreds, and we have to answer the following questions. Is there a guaranteed value on this closed interval such that the average rate of change of cost is equal to C prime of R? Give a reason for your answer. Well, average is a similar or a synonym for mean. So really we're just looking to see if the conditions of the mean value theorem are met. So we need to look for the mean value theorem. It has to be a continuous function on some given interval. So looking here, we have discontinuities at x equals 0 and x equals to -3. But since 0 is within the interval we're looking at, the mean value theorem does not help us. So we are going to say no. There is not a guaranteed value of R on the closed interval 0 to 3, where C prime of R equals the average rate of change, because C of x is not continuous at x equals to 0. So mean value theorem doesn't help us. We can't guarantee that. Next question. Is there a value R on this closed interval 3 to 6 where C prime of R is equal to 0? Give a reason, and if the value R exists, find it. So we're checking the conditions. Let's see. I guess we could use mean value theorem again. Let's see. So 3 to 6. Well, good news is that C of x is continuous on this closed interval 3 to 6. Differentiable. Looks like this would be differentiable. C of x is also going to be differentiable on the open interval, parentheses for 3 to 6. And actually, talking about 0 makes me think of Rolle's theorem. So Rolle's theorem, we had to be continuous and differentiable and have that C of 3 is equal to C of 6. Let's see if that happens to hold. If you go and you take your function C of x and get the values for x equals 3 and x equals to 6, it just so happens that we find that they are equal 8.333.3 repeating. So, by Rolle's theorem, we do have a value of R such that the cost function of R, the derivative, is equal to 0. It says to find it. Let's keep going with the calculator for this question. You can use the calculator. We want to know when it's going to be equal to 0. So if you go ahead and plot even the function, up here, C of x, you might find, you might find that you've got some curve that has a relative minimum. So that happens when, R is equal to 4.098. You can verify that by taking a look at your calculator. And then, last question on this page. For this closed interval, what is the greatest cost for order and transportation? Greatest means highest, means absolute, means we're thinking about extreme value theorem. So let's see. For extreme value theorem, the function has to be continuous on a given interval, and we know that the asymptotes fall outside of this interval. So we know that c of x is continuous on 3 to 9. So that's great. So we just need to find when the function is either, or what the value is at the endpoints. So c of 3 and c of 9, and we need to find when the derivative, when c prime of x is equal to 0 or is undefined. And we will find that we already kind of did this because we found when the derivative is equal to 0 in part B. So we're going to find c of 4.098. And using our calculator, we already knew this one. And this one we'll find is 8,213.67, and this one is 8611.11. So on this interval, so on 3, 9, the greatest cost is $8,611.11. If we were in class, I'd pause and ask if you have any questions, but if you do, you can just send me a quick message and I will do my best to answer any of them. And let's go on to another example here. Now we've got a car company introduces a new car for which the number of cars sold S is modeled by this function, S of t, where t is in months. We need to find the value of S prime of 2.5, correct units, explain what this value represents in the context of the question. So we're going to go ahead and make sure we are able to use our calculator on this question. So we can plug this equation into y1, and we can find S prime by doing, I think it's math 8 for a derivative. And we will find that S prime of 2.5 equals 133.333, at least 3 decimal places. And so what is this saying? This is saying that at time 2.5 months, at 2.5 months, now comes the context, the cars are being sold at a rate of 133 cars per month, using those units there. Now we go on to part B. Find the average rate of change of cars sold over the first 12 months, correct units, explain what this value represents, once again in the context of the problem. So we're finding the average rate of change from 0 to 12 months, 0 minus 12. This can all go into a calculator, and you should get 96.429. And now this is not talking about a specific time, it's an average. So during the first 12 months, an average of 96 cars are sold per month. An average rounding down, same thing in the previous one, rounding down, just contextually speaking. And then we come to the last part of this question. The question is it possible that a value C in this closed interval 0 to 12 exists such that S prime of C is equal to the average rate of change? Average rate of change and S prime are clues for mean value theorem, and so give a reason for your answer if such a value C exists, and find value. So we need to think about the conditions first. The conditions for mean value say that the function has to be continuous on the interval. Well, if we look at this function, we've got a discontinuity only at t equals -2, so that's good. This is continuous on the closed interval from 0 to 12. And the function has to be differentiable on the open interval. And we will find that it absolutely is differentiable, which says, okay, we met the two conditions, we can use mean value theorem. So we can do a little simplifying, and I can find that S of t, just by distributing, is equal to 1500 minus 2700 times t plus 2 to the negative 1. This is what the function is equal to. Same functions here and here. And we can take the derivative.
Friday for you.
You too.
And
This.
question for you. We have to finish one video. We have some groups with kids on grade 10 and grade 11 now. It's just 15.
Pausing for an announcement.
But we can use another room, no problem. Just ask if we can use this one.
No, she's recording right now, actually, and I'm grading.
Forget about what I said. Okay, keep working.
Thank you.
Sorry.
No problem.
I hope you enjoyed that momentary interlude. Now we go back to our work at hand. So we have what S of t is equal to, and now we're going to find the derivative. The derivative of the first term is 0, and now here we're going to multiply. We use power rule, so we're going to have positive 2700 t plus 2 to the negative 2. Technically it's like chain rule, right? But the derivative of the baby is just 1. So S prime of t is 2700 over t plus 2 squared. And we're saying that for mean value theorem, this instantaneous rate of change has to be equal to the average rate of change over the interval. So we need to find what S of 0 minus S of 12 over 0 minus 12 is equal to. But how convenient for us that we already did that. 429. So we set these two expressions equal to one another. We'll have 2700 over t plus 2 whole quantity squared, 96.429. And when you go and do some cross multiplying, we'll find that 2700, 96.429 t plus 2 squared. And doing all of your work out, solving however you see fit, you will find that c is equal to 3.292. This is the value where the instantaneous rate of change is equal to the average rate of change over the interval 0 to 12 inclusive.